Our agenda people today is going to be a complete quadratic breakdown. We're going to take 3 quadratics, simple questions. We're going to factor them. We're going to complete the square. We want to get an idea of what they look like. So we're going to sketch them. And so it's going to incorporate all the skills that we've actually built up to this point. So we're going to start off really simply with a nice quadratic. Let me see if we can get this showing. If I can, give me 1 sec as usual. It's normally the case with me and this thing. All right, so it should be good now. So let us start with, what is this now? Let's go. Something I think we've seen before, x squared plus 6x plus 8. All right, so the very first thing that you're going to look at is what is the coefficient here? All right, the coefficient here happens to be 1. And if it's 1, that means you're going to have a minimum curve. Once this thing is positive, that means that your graph is going to open upward. And so the shape is going to look like that. It's parabolic, it's going to open up. All right, now what else can we find? Well, we can find our root. So let's factorize. All right, and to factorize, we're going to multiply the coefficient of x squared by the constant at the end, c. We're going to get 8. And we're going to say, what are the factors of positive 8 that give us positive 6? Now we know that that would be 4 and 2 in this instance. And so we can write x squared plus 4x plus 2x plus 8 as our quadratic. It's no longer 3 terms, it's 4 terms, and we're on the right track. All right, so let's continue the factorization. This is going to give us x times x plus 4, and whatever we get here, I'm going to write it back here because we need to get this back. And then we're going to ask ourselves, what times x gives us 2x, and that is plus 2, and plus 2 times 4 also gives us 8. Now from these 2 terms here, these 2 are going to factor out x plus 4, and we are left with x plus 4 times x plus 2. Now, how does that help us? Well, this is going to give us, well, it's our factorization. But what we're looking for is the point at which this quadratic, which has been rewritten and factored, y is equal to x plus 4 times x plus 2, the point at which it intersects with y is equal to 0, which is our x-axis, because that's where your roots lie, right? Because your roots of a quadratic are essentially where they're going to cut your x-axis. And to find these points of intersection, we're going to equate these 2 equations, right? So where this equals 0, that is where we find our roots. Now, the logic here is pretty simple. If something times something gives you 0, then either x plus 4 is equal to 0 or x plus 2 is equal to 0. And if x plus 4 is 0, that means x is equal to negative 4. And if x plus 2 is 0, that means that x is equal to negative 2. So these are our roots, all right? Now, if you're comfortable with that, we can actually improve our sketch a bit. Let's improve that sketch a little bit. I'm going to scroll us up to about right here. And from the factorization, if we were to draw our little sketch here, our roots of minus 4 and minus 2, and then I really should have just drawn the quadratic curve before, but yeah, it would look something like this. This is our y, this is our x-axis, and of course the x-axis is where y is equal to 0, and your y-axis is where x is equal to 0. All right, so this is what our sketch looks like so far, but we can get one more piece of information. All right, and that is what we call our extremum, or turning point, right there. This is our extremum, all right, or turning point. In this case, because it curves like this is the lowest point, it's called our minimum point, right? Minima, or if it was turned the other way and it was shaped like this, then up here would be a maxima. But no, minimum point or minimal. All right. Now, what is that extremum? Well, we spoke about completing the square before, right? And if we complete the square, the value that gives us in terms of what can we get the location of our extremum. Now, even before that, let's just use some logic, right? And I'm sketching again, right? This is -2. This is -4. One of the things that you need to know about a parabola is that they are symmetrical, right? They have what we call an axis of symmetry. So if you can literally split them in half with a line, right? That's what symmetrical means, right? And this line should be between the two turning points. So if this is -2 and this is -4, there is a difference between these two of 2, which means that the turning point is 1 unit away, in terms of the x value, from either root. So if this is -2, this is -4, then this must be -3. Right? I'm hoping you can see that. That's a whole lot of writing in one spot, but there is a logic and point to it. So hopefully it's clear enough, right? Now, if the original thing was x squared plus 6x plus 8, we can complete the square. To find the turning point, which in this case we said is a minimum point or a minimal. Cool. Let's do that. We already know that the turning point has an x value of -3, but that's besides the point. That is, I guess, some context for you, and hopefully it helps you when you're working these questions out. So let's complete the square, right? Shift it up a little bit more if we can. All right, we should be good right there. So if I had x squared plus 6x plus 8, let's prove that our minimum point, our turning point, has an x value of -3. We can complete the square, and we're going to end up separating our x's, our terms in x, and leaving our constant on an island by itself, because we're going to make what is in the bracket a perfect square. We're going to end up with what looks like x squared plus 6x, and what is half of 6x? It's 3, and we're going to square it, and that is a perfect square. However, that plus 3 squared was not there, and we don't ever want to change the value of what we have. So since we added it here, we're going to subtract it here, and voila, just like that, we've not changed the value of what we have. That's how that works. So we're just rewriting what we have. So now this is our perfect square, and so it factors nicely to x plus 3 all squared, and this is plus 8 minus 9, and so we end up with x plus 3 all squared minus 1. Now, what does that tell us? Well, the completed square form is simply saying that, hey, I could rewrite my actual first quadratic as that. And if that is the case, our turning point, which I'll call TP from here going on, do with that as you will. TP is what we're saying. Our turning point occurs where this is going to have how can I put this? If it's our minimum point, this has to have its lowest value, right? So essentially where x plus 3 is equal to, that's a 3, equal to 0, which means where x is equal to -3. And that should sound familiar because we knew that already. We did this before. Essentially, we use the symmetry of the parabola to say, okay, if one root is -2 and the other root is -4, then the turning point must occur right between the two, right? And between -2 and -4 is -3. So that works perfectly. Now, having said that, if this is -3, then all of this here becomes 0. And that means that y is -1. And that means your actual turning point is -3, -1. So we can probably scroll up to where we had this before. And right here, this point right here is -3, -1. All right. And this is what I call a complete breakdown because you've actually looked at the original equation. You know that it's either going to be a minimum or a maximum curve based on the coefficient of x squared. You factor to find the roots. Once you found the roots, you get a good idea or an exact x value for your turning point, and then you can find the complete turning point by completing the square. So we're running the gamut of what we can do with a quadratic equation here. So hopefully you're more comfortable with how this works. All right, let's go one more. Let's do another example. I feel like, and this is with all math, it's all about practice, people. And once you practice, you should be fine. So let me get you there if I can. As a matter of fact, let me give us a new page if I can. Get us a new page. All right, here we go. All right, here's another example. All right, our second question is going to be x squared minus 3x minus 10. Now, people, you experience by now, you have an idea what the sketch looks like. The coefficient here is 1, right? And because it's positive, we again have a minimum curve, right? Now, our minimum curve, of course, has that shape. Are we comfortable? We should be comfortable. Now, having said that, let's look at what we can do when we factor. By the way, we also know what the y-intercept is, but I didn't do it in the last question. I guess we can do it in this one. Let us factor, right? And we're going to multiply the first by the last, right? And by first, I mean the coefficient of x squared by our constant, given that we've written everything out in the ax squared plus bx plus c form, right? This is going to give us negative 10. Now we need the factors of negative 10, which sum to negative 3. Hopefully by now, you'd be able to say, oh, I got it. 5 times 2 gives me 10. But if it's negative 10, then one of these has to be a negative term, right? So I can't say 5x times 2x to give me negative 10 x squared. I need to erase that so we can see everything in one line. Let me get it there if I can. I'll be there. Let me shift everything over a little bit. All right. So I can't say that negative 10x squared is just 5x times 2x because that's going to give me positive. One of these has to be negative. However, I need a sum of negative 3x, so I'm going to want the 5 to be negative. So it's negative 5x times positive 2x. So that means that my 3-term expression can now become my 4-term. And again, it doesn't matter which of these two you put first because we have chosen terms that have something in common with not only the first term, but the last term. Not only the term in x squared, but the constant. All right, now let's factor. What's common to these two? X, we end up with x minus 5. We want x minus 5 right back, so we put that down. What times x gives me 2x? It's going to be a plus 2. And of course, 2 times negative 5 is going to give me negative 10. So we're perfect. We're good. We're on the money. So we end up with x minus 5, x plus 2. And this gives us our roots, right? So for the roots, we know that x minus 5, wow, that 5 is special, times x plus 2 is equal to 0, right? That implies that either statements x minus 5 is equal to 0, right? Or, wow, that was, yeah, equally special. X plus 2 is equal to 0. I give up on my handwriting. So that means that x is equal to 5. That's a root. And x is equal to negative 2. Also a root, right? So we'll have one root that's way over on the right side and one root not so much. Cool. All right. Now, we can actually consider our y-intercept. Let's sketch this thing, right? I'm going to scroll down a bit. So we said 5 and negative 2. So let's sketch that. So if I'm going to sketch safe. I'm just going to draw my parabola. 5, negative 2. All right. And I'm going to go, cool. Let's go here. This is my 5. This is my negative 2. Somewhere here, closer to this side, should be my y-axis. This is my x-axis. And remember that the equation was x squared minus 3x minus 10. Our y-intercept here is negative 10, right? But we also know, if we can, that between 5 and -2, we're going to have 5 units on the right side, 2 units on the left side. That's 7 units worth of space, right? Yeah. Which means our axis of symmetry is 3.5 units from either side, right? So if I go 3.5 this way, I'm going to go 2, then 1.5. I'm going to be right about here. And this would be 1.5 or 3/2. Kosha, I don't know if you can read what I'm writing today. I am clearly on something. I don't know why my handwriting is looking like that. All right. Now, having said that, can we prove that? Yeah. To be fair, if we know that this value is 1.5, we could just substitute it into this. We could substitute 4x into this to get the y value. But we're going the whole gamut, running the whole gamut of working with quadratics here. And so we're going to complete the square because that's what we're doing, right? So let's complete the square. I'm going to put completing the square. Kind of heading up, but not so much. So we have our original here. I am separating out my terms in x minus 10. I am then going to make, as you know, a perfect square with what is here. So I'm going to take half of this. -3/2 all squared minus 10 minus that very same thing that I just added, right? And this is going to factor easily because once that last term, the constant itself is half, well, once the last term that is being squared is half the middle coefficient for x, then you have a perfect square. And so this becomes just x minus 3/2 all squared minus 10 minus 3/2 all squared is minus 3 times minus 3, which is 9, 2 times 2, which is 4, and we're almost there, right? We can write this as x minus 3/2 all squared, and is there an easy way to do this? I could look at this as -40/4 minus 9/4, and we're almost there. Dun, dun, dun. I'm going to scroll this up top right here. And we'll end up with x minus 3/2 all squared minus 49/4. I'm pretty sure it was a minus 10. Good. So we're good. Yeah. And if this is our completed square form of our original equation, then our turning point is going to occur where x is equal to 3/2, the value of x that makes this 0, and that means that y is equal to -49/4. And this is the coordinate, or these are the coordinates of our turning point. All right, I think we have just about enough time to do one more. So what was our turning point? 3/2 and -49/4. I'm thinking, yep, there we go. So coordinate wise, I'd write 3/2 and -49/4. All right, we have one more to do before we get out of here. You know what? By now you understand that my belief is firmly that math is practice. So this is par for the course for us. So it's 2x squared is my last one, plus 7x plus 3. All right, let's have at it. Things that we know so far, this is positive and our y-intercept is 3. If we're drawing this, it's going to be, again, a minimum curve, which should be good, right? What else can we do? Well, we can factorize, right? We can say, okay, I'm going to multiply my first by my last term here. 2x times 2x squared times 3, rather, is 6x squared. What are the factors of 6x squared that give us 7? Well, we could use 6x on 1. That should work. Is there anything else? We can rewrite this 3-term expression as our 4-term expression. So we end up with 6x plus x. And on the end we'll have a 3. Let's factor. What's common here is 2x. What's left is x plus 3. I need this back. I'm writing x plus 3 here. What times x gives me x? 1, and completely factorized, I'm going to get x plus 3 times 2x plus 1. But I know you speed running this, you are a star, right? So if I want to find my roots are going to be found where x plus 3 times 2x plus 1 equals 0. That is either where x plus 3 equals 0, which implies that x is equal to negative 3, or 2x plus 1 equals 0, which implies that x, and I can go 2x is equal, implies that 2x is equal to negative 1, which means that x is equal to negative half. So those are my roots, right? And we can sketch that. So we'll have roots of negative 3 and negative half. Let's scroll it a little bit. Should be here. So if I'm sketching, I'm actually going to write the word sketch for no apparent reason. All right. What did we say the roots were? Let me check again. We said negative half and negative 3. Let me get this right. All right. Negative half, negative 3. So this is my negative 3. This is my negative half. And I can just put my y-axis here. My x-axis here, right? Now, what's the spacing here between negative 3 and negative a half? Well, that would be negative 2.5, negative 5 over 2. And so we're looking at probably negative 5 over 4 in terms of a halfway between them. But let us find, if we can, this is, let me go, if this were 3 units here, and I were to half it, I'd be at 1.5. So, if I were to push that over by a half, that should be 2. Let's see. All right, so let us complete the square to see that. Now, to complete the square, we had, what was the original equation? It was 2x squared plus 7x plus 3, right? Cool. Let's separate our terms in x. We're going to go 2x squared plus 7x plus 3u. And then we're going to make this a perfect square, but to make it a perfect square, the coefficient here has to be 1. So we're going to factor out that 2, and we're left with x squared plus 7 over 2x plus 3. And we're good. We're still good. We're going to now work with our perfect square, which is going to be half of this all squared, and half of that is just 7 over 4 all squared. Wow. I'm extending this down here, plus that 3 minus 2 times the thing that we added, right? Because we added it in a bracket where it was being multiplied by 2. So now all we need to do is simplify. Almost there, gentle people. I think we can see it here. Yeah, that works. All right, so this is messy. My teachers back in the day would have killed me for this. So I'm going to end up with x plus 7 over 4 all squared plus 3 minus what looks like 2 times 49 over 16, which is 2 times x plus 7 over 4 all squared plus 3 minus 49 over 8. Did I write the plus 3? No. It's invisible. Yeah, only in my head. All right, we're almost there. Let's make this math easier. We're almost done. X plus 7 over 4 all squared. And instead of having 3, I'm going to write, this is 3 over 1. I'm going to write this as 24 over 8 minus 49 over 8. And so the final line is x plus 7 over 4 all squared minus what looks to be 25 over 8. All right, that's a lot. All right, what does that mean for our turning point? Our turning point is going to occur where what is in the bracket is 0. So where x is equal to negative 7 over 4. And that means that y is simply negative 25 over 8. And so negative 7 over 4, negative 25 over 8. This point here is negative 7 over 4, negative 25 over 8. And there was a y-intercept. If we were to draw this all the way up, it would cut the y-axis at 3. All right, gentle people, that was a lot. Definitely a lot. I am going to ask that you kind of just go through this again, pause where you need to pause. And in the next video, I pretty much want to start moving towards looking at the quadratic formula. We haven't done that yet. We've done everything but the quadratic formula, so that's the next step. And we'll pick up there. We'll talk about things like the discriminant as well and what that tells you. So don't forget to like and subscribe, and see you in the next one.